Welcome back, Alienozer here. So today's teardown is a bit of a special one because we have the CERN beamline CosmicPi, and it's the 105th unit, so it's a little bit special. This one is a prototype. Let's dive in. So a little bit info on the CERN beamline for schools. Me and my team, namely CERN32F401 we participated in this competition a while back, and just now we received our prize, which is a CosmicPi muon detector. It's actually a cosmic ray detector, hence the name CosmicPi. As you can see on the front of the unit, we have the number of the unit, the GPS antenna RF connector, micro USB for programming the Arduino, and a 12 volt power barrel jack. A power and clock LED, a cosmic ray detection LED, and some info on the CosmicPi inside. Well, as the saying goes, don't turn it on, take it apart. Well, I've removed the two Phillips screws required to lift the upper case, so we should be able to open this up pretty easily. One thing before I take this apart, CERN has kindly provided us with some GPS antenna with a long cable and a 9 volt regulated power supply, which is from RS, is pretty good. The lid lifts up pretty easily. As you can see, this is the inside. Okay, I provided some light in order to see the insides better. First of all, we have this Raspberry Pi Zero. It's the W model, which includes the Wi-Fi antenna. It has a couple of jumpers going up to this main board. This is the Raspberry Pi connection to the ARM Arduino chip down there. It's a 32-bit ARM processor from ST Micro. You guys should be able to see some datasheet on this. Next up, we have the crystal for the Arduino itself. We have our GPS module from Quectel, and there's nothing much on the board. There's some regulation going, probably for GPS antenna, which I don't know. It says it's a sensor, but oh, I know, it's the humidity and magnetic field sensor. Probably. On here, there is something which I never knew what it actually does. It's some sort of port or opening for a scintillator port. But this thing inside has a scintillator in order to count the particles, which is the main thing. This is our cosmic ray muon detector. This right here. It is supported by 3 plastic holding thingamajigs. And this thing is a scintillator which amplifies the particles in order to be able to aid us detect the particles. And this thing can detect muons, namely the cosmic rays. I don't know if you are able to see that, but down there are some amplifiers, pretty hefty ones. Probably because of the scintillator's output is pretty low compared to our 5 volt Arduino or 3.3 volt Arduino. So we have amplifiers there, some regulation going down there on that beefy ass capacitors, and some local trigger circuitry, probably to trigger the Arduino and maybe output data to the Raspberry Pi. Well, I noticed something. Come to think of it, there are only 3 connections on the Raspberry Pi and it doesn't connect to anything else. So I'm pretty sure 2 of those are power supply, namely 5 volt or 3.3 volt and ground, and one is some sort of serial or some sort of interface. And well, this concludes the teardown. Now we shall make some measurements. I'll show you the graphical user interface of the 1.6 software. So I prepared this little sticker that says CERN and August of 2019. Well, one thing to look out for is before powering this unit, you have to insert the GPS antenna first and situate your GPS antenna near to a window so it can detect the GPS satellites. Hi, it's raining outside. I'll be using my IBM ThinkPad T40. It's a pretty old model. It runs Linux Mint. I actually do some circuits here from Eagle, but I should get a new computer pretty soon. I'm open to donations. Okay, so I tried to get a screen recorder for Linux Mint installed, but I wasn't able to do that. I think this version of Linux Mint is too old for such a thing, because it gives me an error regardless of what comment I use. So I'm gonna have to do the recording manually. So this is the dashboard. It's a pretty clean interface, as you can see. On the dashboard, we can see a histogram of the events over the last two minutes, with the bin size of 2 seconds. And we can see our hardware information, the UTC time it's currently running on, the humidity, the acceleration, temperature, magnetic field, pressure, and because of the GPS antenna, we can see the longitude and latitude. And this is the 1.6 version of CosmicPi. So yeah, this will show you some histogram. You can do it, set it to auto refresh every 5 seconds, so the histogram changes. This thing has been running for about 2 hours. So you can also select custom plotting. So you can make the device plot a custom graph for you. So you have to enter the times in UTC, Unix seconds form. You can, so basically means we can create plots of the events over the a certain amount of time. As you can see, I have some histograms ready. Alright, this histogram is a morning histogram of my current position. So we at most get 10 or 12. This is the overnight view of our histogram. So we hit about 35 around there. And this is a histogram of my pal's house, my teammate Yildirim's house. So we hit around 40, pretty good. So that was it, guys. Thanks for watching. I plan to add some better LEDs so you can't see the LEDs too much. I'm planning to add some better LEDs and a buzzer when a particle hits this thing. It'll make a sound. So stay tuned. Take care.